Good afternoon, students. So, as you all know, we have gathered here for the revision of the circles chapter. Again, another important chapter for your geometry. So, let's quickly begin with the session. All right. So, we won't take much time on the introduction. So, I assume you guys know how a circle goes about. So, let's start with. So, these are a few examples of circles. So, what you can see is a bangle, ball, coins, boundary rope of a cricket ground. Now, if you observe, it said that out of these four examples, two are wrong. Now, before we see why or which ones are wrong, we need to understand the definition of circle. So, how do you think we can define a circle? I can say a circle is a set of all those points which are equidistant from one fixed point, right? So, now if you look at the ball, if I say the fixed point is the center of this ball, now let's mark at least 2 points on the ball. One can be, say, this point, and one can be at the boundary. Now, if we observe, the distance of these 2 points to the center that we have assumed is definitely not equal. Yes, so we can say a ball cannot be a circle. Coins we already know are cylindrical in shape. Yes, and the same thing applies for the coin. Every point on the coin cannot be equidistant from a given fixed point. So these two are definitely not examples of a circle. Yes, so let's quickly observe now. So we can say a circle is a set of all those points in a plane which are equidistant from a fixed point, and that fixed point is the center of the circle, which is center O. Now, so let's have points on the circle. We have joined OA, OB, OC, OD, OE. All these points A, B, C, D, E are equidistant from the center O. Hence, we can say a circle which passes through all these points will always be a set of points equidistant from the center. All right. What can we say about OA, OB, OC? What are they called? Yes, they're known as the radii of the circle, and we know that all the radii are equal. All right, so we can see we can have infinite number of radii in our circle. Let's quickly move to the other terminologies. If we join any 2 points on the circle, say we have joined CD, what do we get? Yes, students, what is the segment CD called? Let me quickly check if you know your terminologies well. Segment CD, what is it called? Quick, students. Yes, it's a chord. Yes, very good, Pratham. It's a chord. Yes, Kaushik. So we know. Okay, so I assume you guys are cleared with what these segments are called. Yes, this is a chord. How many chords do you think we can have? Yes, Aditya. Yes, Sanjana. Yes, very good. It's a chord. How many chords, people? How many chords in a circle? 4 chords. Okay, Pratham. All right. Anyone else? Infinite. Yes, Pratham, since we have infinite points on a circle, we can join these infinite points, right? And we get infinite chords. Yes, very good, Kaushik. We can have infinite. Yes, Aditya. All right, so we move ahead to the next one. So segment joining two distinct points on a circle is called a chord. We all know that. And we can have infinite chords. The next segment is PQ. Now, this segment PQ, it touches 2 points on the circle, so it is also a chord, but it's a special type of a chord. Yes, it passes through the center of the circle. Yes, it is known as the diameter, and we all know diameter. Yes, Kaushik, it's the longest chord of the circle. Yes, all right. So we know this is the diameter, passes through the center, and is the longest chord. Let's move ahead to the next type of line that we have. Line L. Students, what do you see? Line L, it intersects the circle in 2 points, and M and N. Yes, such a line which passes through the circle is known as a secant. Yes, very good, Aditya. It's known as a secant. So we know a secant is any line which touches the circle in 2 points. It also contains a chord. Students, if you know, note MN. MN is also the chord of the circle. Yes, so secant always contains a chord of a circle. All right, so we know all these segments. We move to the most important segment for your syllabus, which is the tangent. Yes, students, so what do you think a tangent is? Let's draw a line which intersects the circle in only 1 point. So line which intersects the circle in only 1 point is known as the tangent. And this point A is known as the point of contact. So you can see point A is the point of contact. Now, let's quickly, so we have seen the terminologies. Let's quickly have a small quiz round on these terminologies. How many tangents can a circle have, students? Yes, we all know that. How many tangents? How many lines can we draw intersecting the circle in only one point? Infinite, yes, Kaushik. Okay, Mahi, infinite. Yes, some more answers before we move to the answer. All right, yes, Pratham, infinite. Yes, all right. So that's correct. That's perfectly correct. We can have infinite. Quickly observe. So we have another tangent. Yes, even at this point we can have a tangent. Yes. All right. So we can see we can have infinite such tangents, right? Infinite points on a circle. So definitely infinite tangents. Yes. So the answer is we can have infinite tangents. Now, a circle to a tangent to a circle intersects it in how many points? How many points? Yes, only one. Yes, that's correct. It has to intersect the circle in only one point. That's correct. We move ahead. A line intersecting in 2 points is then called what? So tangent intersects the circle in one point. So yes, a line intersecting the circle in 2 points is definitely a secant. Yes, that's correct. Yes, Kaustubh. Thank you, Aditya. Yes, it's a secant. Yes, very good. All right. Let's move to the next question. A circle can have how many parallel tangents at the most? Yes, Aditya, pretty quick. Yes, Kaustubh. Yes, it's two. Yes, so please observe. Here we have a tangent line, say L. How many tangents can be parallel to this L? Yes, we can have only one, right? Say line M, which is exactly opposite to this tangent line. So definitely two parallel tangents at the most. Yes. So we move ahead. Now, the common point of a tangent to a circle and the circle is, yes, Aditya, very good. Yes, it's the point of contact. So point A. As we can see, point A is the point of contact. Yes, very good. All right. So we're done with this. Let's quickly move to the important theorems in your chapter now. So the first theorem that we have is that of the radius and the tangent. Yes, this theorem is based on the radius and the tangent. So let's quickly move to the theorem now. So the theorem goes like this. A tangent at any point of a circle. So when we say a tangent at a point, we mean point A, which is also known as the point of contact. So this tangent is always perpendicular to the radius. So you can see we have radius OA out here. We have tangent line L. And what does the theorem say? This radius and tangent are always perpendicular to each other, but at a particular point, which is the point of contact, point A. So I can also say segment OA is perpendicular to line L, or what else can I say? Let's see, if I have another point B on the tangent, I can also say angle OAB is 90 degrees. Angle OAB is 90 degrees. Yes, that's correct. People, before we move ahead, we need to study another concept known as the tangent segment. So we will study another concept, which is the tangent segment. Let's quickly see that. So we are going to study what a tangent segment is. Yes. Now, students, we already know what a tangent line is. Yes. A tangent segment, now, students, pay attention. Any segment on the tangent line with one endpoint as the point of contact, and the other point can be any point on this tangent line. Such a point is known as, yes, Kaushik, here it is tangent segment AB. Now, if I say another point C, if I take another point C, can you point out to another tangent segment? Do we have one more tangent segment out here? Yes, students? So please observe here A is the point of contact and C is any point on the tangent line. So can I say AC is the point of is the tangent segment? Yes, Kaushik. AC is the tangent segment. What about BC? Yes, students, what about BC? Is BC also a tangent segment? 2 points on the tangent line. Does that make a tangent segment? Yes, students, what about BC? Is BC a tangent segment out here? No. Okay, Prathamesh, no. Aditya, yes, no. No, it's only a tangent. Yes, students, we can just say BC is a tangent line. Since B and C, none of them are the point of contact, BC can never be the tangent. Pratham, please observe B and C. As I said, for a tangent segment, one endpoint has to be the point of contact. As we can see, B and C are just two random points. We don't have a point of contact, so BC cannot be the tangent segment. I hope you all have understood, because this concept is extremely important for your coming theorem. All right, so in this theorem, we have seen radius OA is always perpendicular to the tangent line, which is line L. You can also call it as BC, or you can also say OA is perpendicular to AB out here. All right, we move ahead. Now, whenever you use this concept in your problems, you need to write this segment. Radius is perpendicular to the tangent. This statement needs to be written. All right, now quickly let's move to the sums. Okay. TP and TQ are two tangents to a circle with center O. Now, students, we have all studied the circles chapter. We know the theorems. We know everything. So, this revision lecture will mainly focus on how to approach or how to attack any problem. Yes, so we will see how you need to start with the solution when you have a given problem. Okay, I see some masterminds out here who are giving me the answer. All right, let me first explain it. Yes, very good. We have 70. All right. So let's start with the sum. We have TP and TQ as two tangents to a circle with center O, so that angle POQ is 110. We need to find angle PTQ. So we have this angle out here marked by question mark. Now students, pay attention. If you observe OPTQ. Yes, what do you see? OPTQ is a quadrilateral. Yes, so can we apply sum of angles of a quadrilateral? For that, we need to know the measure of angle P, and also we need to know the measure of angle Q. Yes, students, what's the measure of angle P and Q? Can we guess what the measure is? Any guesses? 90? Yes. Yes, students, yes. So we have just seen OP is the radius, TP is the tangent. What do we see? OP and TP are perpendicular. Yes, so angle OPT is 90. Similarly, OQ is the radius, TQ is the tangent. Angle between the radius and the tangent is 90. So what do we get? Two angles out here are 90. Now quickly we can apply the angle sum property of a quadrilateral. Yes. So what do we have? We have POQ as 110, P as 90, and Q as 90. So what do we get? 110 plus 90 plus 90 is 290 plus PTQ. The total sum has to be 360 degrees. Yes, as we can rightly see, PTQ is 70. You all have calculated before I could ask you all. Yes, it's definitely 70 degrees. All right, we move ahead. Let's move to the next question. Now, people, before we understand how to solve the question, it's very important to evaluate the question and draw the correct diagram. Now, if you observe, the diagram is already out here, but just in case you had to draw it, how do you do this? You have a tangent PQ. All right, so right now we just know we have a tangent PQ, but it says at a point P. Students, this is a very important word. The moment we know tangent is at a point P, this P becomes the point of contact. Automatically, Q has to then be the external point for the circle. Yes, at point P means tangent touches the circle at point P. P is your point of contact. Now we know radius is 5, so definitely OP is 5. Now, so a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O. So a line through center O has to be line OQ. So that OQ is 12. Now we definitely know that radius is 5 and OQ is 12. We need to find PQ. That means we need to find the length of the tangent. Now students, if you observe, this is just any random triangle right now, and we cannot say anything about PQ, right, unless we know something specific about the triangle. For example, say if it's an isosceles triangle, then we definitely know two sides are equal. If it's a right angle triangle, we know we have to apply the Pythagoras theorem. So let's see, what do we know? So let's start with the problem. So we have a radius out here and we have a tangent, and we already know radius OP and tangent PQ have to be perpendicular to each other. Now what do we get? OPQ, triangle OPQ is a right angle triangle. Yes, okay, all right, I'm getting some answers. All right, so students, OPQ is a right angle triangle, and now we have already studied, right? On any right angle triangle, we can find the third side using Pythagoras theorem. So let's see. Okay, I have some answers. 13. All right. So for this, Atharva, Aditya, Pratham, 13. Please observe, is PQ the longest side? So 13, right? You've got it more than OP and OQ, which is 5 and 12. Is PQ the longest side of this right angle triangle, students? No, please observe. The right angle is at P, and always the side opposite to the right angle is the hypotenuse, which is the longest side. So 12 is our longest side. Our final answer has to be less than 12, yes? Yeah, so please observe. We start applying the Pythagoras theorem. OQ square is OP square plus PQ square. Yes, we know that 5, 12, 13 are a Pythagorean triplet, but please observe 12 is already the longest side. So we need to get something less than 12. Yes, you can see out here PQ square is 12 square minus 5 square, which is 144 minus 25, 119. Yes, 119, you cannot factorize it further. So we leave it under the root just the way it is. All right, we move ahead. Okay, the next sum is a very similar sum, but I'll be taking it because we need to understand the terminologies of this sum properly. Now pay attention. In the previous sum, you had a tangent at a particular point. What do you see out here? From a point Q. So when we say from a point Q, it means any random point Q. So can I say Q is the exterior point of the circle? Whenever you have from a point Q, that means Q cannot be your point of contact. Q has to be an exterior point. So now observe, let's move ahead. From a point Q, we have a tangent to a circle, which is, okay, now from a point Q, length of tangent to a circle is 24 and the distance of Q from the center is 25. So distance of Q from the center is OQ, which is 25. Length of tangent, which is PQ, is 24. Find the radius. Now you can again see we have radius OP and tangent PQ, and they are what? Perpendicular to each other. Yes, radius is always perpendicular to the tangent. Now you can use Pythagoras theorem on this triangle. Yes, I can see some answers. Yes, Aditya, Atharva, very good. Ajay, yes, it's 7. All right, so we already know what we need to evaluate is 25 square is 24 square plus, we can say OP square, we can do this. 625 minus 576 is 49. Root 49 is OP, which is 7. Yes, students, so we know that since 25 is the longest side, we already have it. Any answer that we get has to be less than 25. All right, so you need to rightly observe which is the hypotenuse. And please pay attention, any answer that you get has to be less than the hypotenuse then. Okay, we move to the next question. All right, this question we'll be skipping since we have already considered two cases, tangent at a point or from an external point. So we will skip this. As you can see, let's just quickly move through the sum. OA, as you can see, is the longest side. We will have a right angle out here. And now students, you know, right? 3, 4, 5 form a Pythagorean triplet. Ritanshu, you cannot hear me? Does the problem exist? Okay, you cannot hear me properly. Can you call on a number that I'll give you? Take down a number. I'll just type it out here. So anyone, any system related issues, please try to refresh your page. In case the issue persists, kindly contact on this number. So I'm typing that in the chat. You all can note this down. Even for further assistance, you can always contact on this number. All right. So, okay. All right. You can hear. That's great. Yes. Okay. In case of any issues, people, you can always contact on this number. Yes, Sultanshu, very good. You can hear me. All right. So we skip this sum because we know OB is definitely going to be 3 because 3, 4, 5 form a Pythagorean triplet. All right. Students, I would always advise perfect squares up to 30 should be remembered. It is a must. You cannot afford to waste time finding squares up to 30 during the exam. All right, so please take that as a request. Squares up to 30 should be learned. All right, we move ahead. Okay, so we move ahead to the next sum. We know this is 3. All right, now the next question. Students, pay attention to this question. All right, like I said, we will see how to approach the sums. Okay, now O is the center of the circle and we have BCD as a tangent. Students, BCD is just a straight line. So you can also call it BC or BD or CD, doesn't matter. BCD is a tangent. That is all that we know. To it at C. C is your point of contact. Now, prove that angle BAC. So let's see which angle are we talking about. Angle BAC is this plus angle ACD. Which sum do you want, Pratham? The previous sum? Do you need explanation of the previous sum? All right. I assume it's the previous sum, so we'll move to that again. All right. Okay, Pratham. Pratham, please observe. So in this sum, it's given that length of tangent from A. Whenever you know it's from A has to be the exterior point. So from A, we have a tangent to the circle. AB is the tangent. Now, the length of tangent from a point A at a distance 5 centimeters. Students, the English formation of these statements need to be understood properly. Right now, if you see, point A at a distance 5 centimeter from the center of the circle. So this A is at a distance of 5 from the center. So OA is 5. And they said, now pay attention, length of the tangent is 4. That is how your sentence formation goes. That's how we know that AB, which is the tangent, is 4. Find the radius of the circle. First and foremost, we need to conclude what type of a triangle is this. So definitely OB is perpendicular to tangent AB. Radius OB is perpendicular to tangent AB. The first theorem we apply is this. Now, since we know this is a right angle triangle and we know two sides of the triangle, can we apply Pythagoras theorem? Yes, definitely. And what do we know? Hypotenuse square, so OA square, is the sum of the squares of the remaining two sides. AB square plus OB square. So 5 square is 4 square plus OB square, which is the radius. 25 equal to 16 plus OB square. We need to shift 16 on the other side. Plus becomes minus. 25 minus 16 is 9. OB square is 9. Taking square root on both the sides, what we get is OB is 3. Yes, Pratham. Now is that okay? All right. Yes. So, and we all know, right? We should know 3, 4, 5 form a Pythagorean triplet, is what I meant. 3, 4, 5 are will always be sides of a triangle, with 5 being the hypotenuse. All right. So we move further. All right. There's some people we were looking at. We have already seen BCD is the tangent. We need to prove angle BAC, which is this angle, plus angle ACD is 90 degrees. Students, observe BAC plus ACD is 90 degrees. Right now, if you look at this, BAC and ACD have nothing common between them. Yes, so please observe, students, we need sum of two angles to be 90. But in our circles chapter, is there any theorem which talks about angle between two segments to be 90 degrees? Yes, students, observe. Now, before we move ahead, I will give you a trick to solving the sums in the circle chapter. Please observe, please note this down if you want. Whenever we have center of a circle and point of contact, always make sure you join the center and the point of contact. Before you do anything else, always join the center and the point of contact. So I'm going to join OC. Yes, this is a trick. You will always do this, irrespective of what the sum talks about. All right. Now that you have OC, students, can I say OC is the radius of the circle? Yes, definitely OC is the radius. We know BCD is the tangent. So which theorem can we apply? Yes, we have just studied one theorem. And what do we know? Radius and the tangent are always perpendicular to each other. So what we know is angle OCD is 90 degrees. Yes, students, angle OCD is 90 degrees. So we have not got this. We need sum of two angles to be 90, but we know that OCD is already 90. Now, is OCD sum of two angles? Let's see, can I write OCD as... All right, Prathamesh, I don't get what you're saying. Okay, oh, all right, all right. Okay, so can I write OCD as angle OCA plus angle ACD? Yes, OCD can be written as OCA plus ACD, and that is equal to 90. All right, okay. Now, students, observe ACD. Do we already have ACD? Yes, we already have ACD in our equation, right? So all we need is, if I can somehow replace OCA with angle BAC, our work is done, right? We somehow need BAC instead of OCA because we already have ACD, we already have 90. So now just look at OCA and BAC. All right, let me change the color so that we can point this out properly. All right, yes. Okay, students. Now observe angle OAC and observe angle OCA. BAC can also be written as angle. Okay, so BAC can also be written as angle OCA. All right, students. Pay attention. So BAC is angle OAC and OCA is this angle. Now let us look at these two angles. Come on. Let us look at these two angles. Are these two angles angles of a triangle? Yes. Look at triangle OCA. In triangle OCA, what do we see? OC and OA. They are the radii of the same circle. Yes? Yeah. Now can you see? I've changed the color, Kaushik. I've changed it to red. Yes. Okay. So OC and OA, two sides of the triangle, are equal. So what kind of a triangle is this? It is an isosceles triangle. And we have already studied this in our previous years, that in an isosceles triangle, when two sides are equal, their base angles or angles opposite to equal sides are equal. So can I say angle OCA? So I can say angle OCA is equal to angle OAC. Yes, these two angles are equal. And look at angle OAC. Angle OAC can be written as angle BAC. Yes, so I'm going to write angle OAC as angle BAC. Since OCA and OAC are equal, now I can just replace OCA with angle BAC. BAC plus ACD is 90 degrees. Students, have you understood this? I will go through the steps as well so that you understand, but I needed to explain how to attack any given problem. Please observe. So what do we have out here? We have, yes, we have OCA and OAC equal because they are angles, base angles of an isosceles triangle. Now we also have angle OCD equal to 90 degrees. So let's observe. OCA plus ACD is 90. OCA plus ACD is 90, and we already saw OCA and BAC are equal. So instead of OCA, we have just replaced OCA with BAC. All right. Okay, so I understand that you all have understood this sum. Let's move to the next one. So always observe whenever you get a sum, try to break the sum into bits and pieces that you know, that you already know. Okay. All right. So we move to the next sum. Okay. This is again another very easy sum. Pay attention. Prove that angles between the two tangents. So we observe we have two tangents from external point P, PA and PB. Angle between that tangent is angle P. Drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact. Students, now observe, in case this diagram was not given to you, how do you draw this diagram? So pay attention, I'll be breaking this diagram for you. We have two tangents drawn from one external point. So first, from an external point, we have drawn two tangents, PA and PB. Now, it has to be supplementary to which angle? Angle subtended by the line segment. Now, students, you must be wondering, we don't have a line segment. So let's see what is this line segment that is being talked about. Line segment joining points of contact. So we have one point of contact A, second point of contact AB. Can I join AB? Yes, I can definitely join AB. This is the line segment we are talking about. Now, this line segment subtends an angle. Students, subtends only means making an angle. So this AB makes an angle where? At the center. Now, this segment can make only one angle at the center, which is AOB. So the two angles that we are talking about are APB and AOB. And they have to be supplementary. So the sum has to be 180. We already know supplementary angles means angles which make a sum of 180 degrees. Okay. Now that we have understood how to draw the diagram, now that we know what we need to prove, let's quickly move to the sum. Okay, so what do we see? We have tangent AP and radius OA. OA and AP meet at this point of contact A, and what do we know? Radius is always perpendicular to the tangent at the point of contact. So can I say angle OAP is 90 degrees? Yes, definitely. Similarly, we have radius OB, tangent PB, and radius OB and tangent PB are also perpendicular at the point of contact B. So what do we get? B is also 90. Yes. Now students, pay attention. A is 90, B is 90, and O and P are the remaining two angles of our quadrilateral OAPB. Remaining angles of quadrilateral OAPB. So now all we are going to do is apply angle sum property of quadrilaterals. So we have angle A plus angle P plus angle B plus angle O. Students, for convenience purpose, I'm using single letter for the angles. You will always mention the angle as a 3-letter name. All right. So angle A plus P plus B plus O is 360. We know A is 90. P is 90. We leave the remaining two angles. Look at the remaining two angles. APB, yes, is that what we need? Yes, definitely. AOB, that's the other angle that we need. All right, very good. That makes it very easy, right? 90 plus 90 is 180. We shift 180 on the other side. Plus becomes minus on the other side. What remains is APB plus AOB is 180. If sum of two angles is 180, they have to be supplementary. Yes, does that solve our problem? Any doubts still here, students? Anything that you have not understood? If I'm going fast, please let me know. No, right? No doubts? Okay, no. All right, that's very good. Okay, so yes, all right. So I believe everyone's paying attention. Very good, Kaushik. We move ahead to the next sum based on your theorem. Two concentric circles are of radii 5 and 3. Students, I know you can already see the diagram out here, but just in case you don't know, let's quickly revise what concentric circles are. Concentric circles are any two circles which have the same center. So you can see we have two circles having same center O but different radii. Okay, Atharva and Aditya, very good. All right, first I'm going to explain this sum. Okay, so we have center O and two different radii. So we have two circles, one with radius OP, which is 3 centimeters, another circle with radius OB, which is 5 centimeters. All right, Kaushik, Pratham, very good. Okay, so we move to the sum. Find the length of chord AB. This is the chord we're talking about of the larger circle, which touches the smaller circle. Students, we can see AB is the chord of the larger circle, which touches the smaller circle at P. Okay, a lot of people know the answer already. So quickly, let me see how we can do this sum. So we need to find the length of AB. This is our aim, to find AB. Now, students, pay attention. First thing, let's look at AB. AB and OP. OP is the radius of the smaller circle and AB touches the smaller circle in one point P. So can I say AB is the tangent to the circle? Yes, definitely. OP and AB are perpendicular to each other. So angle OPB is going to be 90 degrees. Now students, the moment we realize angle OPB is 90 degrees, there are two conclusions. First, OP, that is segment from the center of a circle to the chord, is perpendicular to the chord. Yes, very good, Kaushik. So from O, we have segment perpendicular to the chord. We already know the theorem from our ninth standard. A perpendicular drawn from the center of a circle to the chord bisects the chord. Yes, very good. So what we understand is AP is equal to PB. Let me quickly mark that AP and PB are equal. Now that we know that OPB is a right angle triangle, can we find PB? Yes, students, can we find PB? Yes, definitely. It's a right angle triangle, right? What do we know? OP is 3, hypotenuse OB is 5. So what is the value of PB? Students, what is PB? Yes, Dhwani, very good. PB is 4, right? What do we get? 5 square minus 3 square is PB square. We can evaluate this. 25 minus 9, 16. 16 is PB square and under root 16 is 4. Yes. So students, PB is 4. We know that PB is equal to AP. So even AP is 4. And what do we understand? AB is AP plus PB, which is 4 plus 4, 8. Is that understood, students? That is how we get the length of AB. Let's quickly see how do we write the steps. The first thing we do is we observe that OPB is 90 degrees because radius is perpendicular to the tangent. Next, what we do is we find the length of PB, which is 4. Yes, we know that. And the next thing what we need to say is that perpendicular from the center of the circle to a chord bisects the chord. Student, it's extremely important to write reasons. The moment you miss a reason, your half mark gets cut immediately. All right, that's how we get 4 plus 4, which is 8. All right, students, any doubts out here? Any doubts with this sum? Anything that's not understood? All right, no, okay. All right, Atharva, yes, Ajay. Okay, thank you so much. So we move to the next question. All right, again, students, if you observe, we have two concentric circles out here. Let's quickly see what is given. So two concentric circles with center O of radii 5. So we have the first radius, which is the bigger radius as 5. Second radius, which is OB, is 3. Now, from an external point P, there are two tangents drawn, PA and PB, to these circles. All right. If you see, PA is a tangent to the bigger circle, PB is a tangent to the smaller circle. All right. Now, AP is given to be 12. We already know the radii. What we need to find is BP. Students, again, let's start from what we know. So as you can see, we have some tangents out here. We have the radius of the circle. So first and foremost, let's apply the theorem. Length of, okay, so the tangent and radius are always perpendicular to each other. OA perpendicular to PA. Similarly, OB perpendicular to PB. Now that we know this, let's quickly look at BP. BP belongs to right angle triangle OBP. Yes, OBP. Now, if you look at right angle triangle OBP, we don't know two sides, right? We don't know PB and we also don't know PO. Can we find PO first? Yes, definitely we can find PO from triangle OAP. From triangle OAP, we are first going to find OP. Yes, we will first find OP. Now, students, we can apply the Pythagoras theorem. Let's quickly apply the Pythagoras theorem. Yes, students, first I want the answer for OP. Everyone, I can see people writing answers for BP. First, I want to know what OP is. Come on, quickly apply the Pythagoras theorem. OP square is AP square plus OA square. Yes, OP is 13. Yes, Neha, thank you. Atharva, yes, thanks. Himangi, Sai, yes, thank you so much. Yes, very good. So we know OP is 13. Now it's easy, right? OP is 13. Now students, pay attention. OP is 13. Now can I apply Pythagoras theorem? Yes. We know PB square plus OB square is equal to hypotenuse square, which is OP square. Students, here it's very important to understand that you do not replace BP with OP. Yes, the longest side is always opposite to the hypotenuse. So it is OP square is PB square plus OB square. Let's quickly substitute. OB square is 3 square, which is 9. OP square is 13 square, which is 169. So what we get is under root 160. Yes, 9 shifts on the other side. Under root 160, students. You can factorize 160 further. You can factorize 160. What do you see? 16 into 10. Students, always understand, if you leave your sum to this point, you will lose marks. So you factorize 160, 16 into 10. 16 being a perfect square, we get 4 outside the root sign. 10 cannot be factorized. Keep root 10 as it is. Another important thing which students miss out is centimeters, the units. If the unit is given, make sure you write it as centimeters, meters, whatever, or you definitely have to write units. Yes? All right. We move to the next sum. Okay. Oh, that's great. Someone's found Pratham. All right. You don't need to do this. 4 root 10. Okay. You don't definitely need to do this, but if you do this, yes, definitely. You can do this. You can find root 10 if you have a lot of time, though. Don't do this before you solve all the other sums. Okay. We move ahead. All right. The next sum we have is a sum on proof. So pay attention. Prove that tangents drawn at the ends of a diameter. Usually, students, when we have such sums to prove, the diagram is not given. So first step is to understand the diagram and draw it properly. Will we lose marks for that? Okay, to do anything extra, you don't lose marks. But if you leave it at 4 root 10 on the previous slide, if you leave it at 4 root 10, that's definitely fine. So I request not to waste time on that unless you have a lot of time. Okay, you don't lose marks. Okay. All right, so we move to the next sum. Prove that tangents drawn at the ends of a diameter. Okay, so we move to the next sum. Okay. Tangents drawn at the ends of a diameter of a circle are parallel. So what you need to show is you have a diameter AB and you have two tangents drawn at the ends. That means A and B are your points of contact. Yes, and you have two tangents passing through A and B. So your tangents are PQ and RS. You need to prove PQ and RS parallel. Now students, let's go back. Forget the circles chapter. Let's go back to our basics. If we need two lines to be parallel to each other, what do we need to prove? We have three things that we can prove. Either alternate angles. Yes, we can get a pair of alternate angles which are congruent. We can get a pair of corresponding angles which are congruent, or a pair of co-interior angles which are supplementary. Co-interior angles need to be supplementary. Now, if we look at this diagram, so keeping this in mind, if you get any of these three angles, then if you get any of these three, then your work is done. Yes, so let's move. Let's quickly see what we can get. Now, moving back to the circles chapter, we can see OA is the radius, PQ is the tangent. So can I say OA is perpendicular to PQ? Yes. Similarly, OB is perpendicular to RS. Yes, students, as we can rightly see, A and B each are 90 degrees. And students, observe for lines PQ and RS on transversal AB, angle A and angle B happen to be the interior angles. In case you all don't remember, we know that the letter C, angles within the letter C are always co-interior angles. So 90 plus 90, 180, and they are supplementary. Interior angles are supplementary. Therefore, we can definitely say that PQ and RS are parallel to each other by interior angles test. Student, you cannot get confused when to write test and when to write theorem. Yes, when do we write theorem, students? Here we have written test. When do we write the word theorem? Interior angles theorem. Yes, students, anyone? When will we be using the interior angles theorem instead of test? All right, anyone? I'm waiting for an answer. Okay, all right. So I will let you all know when do we use the word theorem. Students, if it is given that the two lines are parallel to each other, and if we prove that the interior angles are supplementary, then we say by the interior angles theorem, the angles are supplementary. So when it is given that lines are parallel, we use the word theorem. If we are proving the lines to be parallel, then we always say interior angles test or alternate angles test or corresponding angles test, provided which method we use. I hope I have solved this confusion. Yes, students, please make that note. All right. Okay, so we move ahead. Okay. Moving ahead to the next sum, prove that perpendicular at the point of contact to the tangent to a circle passes through the center. Now, students, let's break this sum and understand. What are they trying to say? Perpendicular at the point of contact. So, here, the perpendicular they are talking about is segment PT. As you can see, they have drawn or they have given that PT is the line perpendicular to AB. This is given. Next, we need to prove that this line PT, this line also passes through the center. PT passes through the center. We need to show that PT passes through O, or in short, P dash O dash T. Yes, students, in mathematical form, what does it mean? That P, O, and T have to be collinear points. Now, students, pay attention. For P, O, T to be collinear points, segment PT and segment OT should be one single line. This is what we are going to prove, that PT and OT are the same line. So students, pay attention, since this deals with the concept, you need to pay attention to this. So let's start with the proof. The first thing we know is we have PT perpendicular to AB. That is something that is given. Yes. Next, students, what do we analyze? What about OT and AB? Look at OT and AB. OT is the radius of the circle. AB is the, all right, okay, Kaushik, no issues. AB is the tangent to the circle. So can I say OT and AB are also perpendicular to each other? Radius is always perpendicular to the tangent. Okay, all right. So now we have two perpendicular lines. Students, observe these two perpendicular lines carefully. Now, before I move ahead with this, I need some concept. I need to see if that concept is known to y'all. If I have one straight line L, and to this line I am drawing, okay, two perpendicular lines. All right, please observe, these are perpendicular lines. So say M and N are perpendicular to the same line L. Students, observe, I have line L and I have M and N perpendicular to the same line L. What can I say about M and N? Students, can we conclude anything about the relationship between M and N? What kind of lines are M and N? Yes, students. Prathamesh, parallel. Yes, Kaushik, parallel. Sneha, yes, very good. They are parallel lines. Students, this is known. If two lines are perpendicular to the same line, they are parallel to each other. And why are they parallel? These are corresponding angles, right? Corresponding angles are equal, so the lines have to be parallel. But students, pay attention. Out here, we have slightly similar case. We have two lines perpendicular to the same line AB. Yes, we have two lines PT and OT perpendicular to the same line AB, but if you observe, they are perpendicular at the same point. Now, students, at one point, how many lines can we draw? We can draw a single line, right? We can draw a single line at one given point T. That means PT and OT have to be the same straight line. They cannot be two different lines, right? Because they meet AB at a single point, they have to be the same line. Hence, we can conclude PT and OT are one and the same line. They cannot be two parallel lines. They are one and the same lines. And hence, we can say POT are collinear points, or PT has to pass through center O. Students, this was a slightly conceptual sum. Please let me know if anyone has any doubts with the concept in this sum. It's slightly conceptual, so I need to know. Any doubts with this? All right.